Without a doubt, you will perform filtering with BGP. You're not going to want every single route from the internet. You're not going to advertise every single route to the internet. So therefore, you're going to be playing around with route maps, filter lists, prefix lists, and the order of operations matters because the BGP table is going to contain all the routes that we learn or the routes that we advertise to the neighboring devices. The order that the route maps, filter lists, and the prefix lists are applied is very important. As you can see, if we have an incoming route, the route map is processed first. After that, filter lists are processed, and then after that, prefix lists are processed. So if you have a certain route that you are trying to manipulate and you implement a filter list or a route map or a prefix list, and there is some other list or map configured as well that affects that traffic, you might not be getting the results you expect because of the order of operations, the way they're processed. The same thing is true when you're advertising routes to neighbors. Prefix lists are checked first, then filter lists, then route maps. So if all of a sudden that prefix list is filtering out information that you are trying to modify or change in a route map as it's being sent to that neighbor, well, the filter list is already, or the prefix list has already filtered it out. It's not even making it there. So again, you have to be aware of the order of operations here for filtering and processing those routes as they're coming in and out of our BGP table. Like you witnessed with IPv4, you will want to filter certain routes. And we can accomplish that using prefix list because the prefix list gives us the ability to specify the address plus the mask that is associated with that particular address. So in this case, we're using IPv6 prefix lists in our IPv6 environment, and we named this particular prefix list large networks. So I assume we are either going to be filtering out large networks or allowing large networks. And it says here permit, so it looks like we're going to be allowing those large networks. And what do they classify as large networks in this case? Well, they classify anything within this range of addresses that have a mask that is less than or equal to 48. 48. Do you recall what ISPs hand out to large organizations? That's right, they're handing out /48 prefixes to those large organizations. So right now we are only going to be permitting those addresses, those networks, those routes that are /48s. But what is the overall range here? Remember, less than or equal to means this is a range of values. Well, if we think about it from a wildcard mask perspective, this would be stating that the first 3 bits have to match, but the rest of them can be anything we want them to be. So what are the first 3 bits in this case? Well, every single hexadecimal value represents 4 bits. So that 2 that we see right at the beginning is what in binary? It is 0, 0, 1, 0. That's what it is. So /3 says the first 3 bits have to match. So that means in that very first hexadecimal value, it could be a range from 0010 to 0011. Well, what do these equal? Well, 0010 is 2, 0011 is 3. That's what that equals. So our range here is any IPv6 route that starts with a 2 or a 3 as the very first hexadecimal value, and then nothing else matters. It could be any other value. So the total range within that first quartet is going to be any address from 2000 all the way to 3FFF is going to fall within this prefix list. Right now, that is the global IPv6 unicast range of addresses that are being handed out to customers. And the subnet mask is going to be less than or equal to 48. So if we look down below now at how it was applied, we can see that the prefix list for neighbor 2001 DB8 2:2, it says that we are applying it inbound. So any routes we receive from R2, because we're on R1 right now, any routes we receive from R2 can only be within the range from 2000 to 3FFF with a subnet mask or a mask less than or equal to 48. I will only send to that neighbor the same range of addresses, 2000 through 3FFF with a mask less than or equal to 48. So if we look at the examples up at the top, if R1 or R2 advertise 2001 DB8 2:1:/64, will that be a route that is advertised or accepted? No. Why? Because the mask is /64. Even though 2001 falls within the range of values from 2000 to 3FFF, this subnet mask is wrong. Therefore, that won't be advertised between the two. What about AF01? No. No, because that doesn't even fall within the 2000 to 3FFF range. Even though the mask is /48, which is what we're accepting less than or equal to 48, it will not, in this case, be advertised. But this one will be 2001 because it falls within the range, and the mask is /32, which is less than or equal to 48.